Welcome to this explainer. Today, we're popping the hood on the Hotot System. It's an award-winning edge computing framework that is literally revolutionizing how we handle remote sensing data. If you've ever found yourself wondering how modern defense and intelligence operations manage the absolute avalanche of sensor data out there today, well, you're exactly where you need to be. Our main goal right now? Unpacking exactly how the Hotot System actually works.
So, let's jump right into the big, universal challenge here. Imagine you're running a massive defense op or a disaster response mission, right? You've got thousands of sensors, cameras, mics, thermal detectors, just scattered everywhere across the field. The old-school way is to take all that endless, raw data and stream it back to a central hub for human operators to watch. But in high-stress, resource-constrained environments, doing that is practically impossible. Your bandwidth gets totally choked out, and your operators end up suffering from massive cognitive overload.
It's basically a tale of two systems. On one hand, you have the old way, just completely drowning your operators in constant, raw data streams. It's just too much. But then you have the Hotot approach. Instead of sending absolutely everything, the Hotot system actually processes the data locally, right at the source, and sends back only tiny, actionable edge alerts. This is a real game changer because it drastically lowers bandwidth usage and gives you automated, meaningful insights instead of just a giant wall of static and noise.
Okay, Section 1. Meet the Hotot System, a containerized system of systems. Let's look at how this architecture acts as the ultimate overlay to solve that huge data bottleneck we just talked about.
Now, what is truly disruptive here is that Hotot isn't some brand new, super expensive suite of physical hardware. Not at all. It operates entirely as a containerized software overlay. This means it just seamlessly integrates into your existing computing environments, taking your current kind of dumb hardware and transforming it into a highly intelligent system of systems. So there is no need to rip out and replace all your expensive legacy sensors just to get these advanced capabilities.
To really understand how this works, we need to look at its DNA. The whole framework is built on three specific copyrighted software components that work together in total harmony. First, you've got the persistent dynamics intelligent tasking for dynamic coordination. That's the central brain handling the decision-making logic. Second, there's the Hotot agent utility package. And third, the Hotot server. We're going to break down those last two right now because they really form the operational backbone of the whole setup.
Which brings us to Section 2. Agents and central servers, distributing the processing load. To really grasp how this data processing happens out in the wild, we've got to look at the two main software actors here, the agents out on the edge and the central server.
So the crucial point to remember is that the Hotot agent utility package sits right on the sensor itself. It's this super lightweight piece of software deployed directly onto individual edge sensors, where it intercepts raw inputs on the fly. And when I say edge sensors, I mean a camera on the ground, a drone flying up in the air, or literally a satellite out in space. The agent is right there, sitting on the front lines.
And this is exactly where the real local data transformation happens. The agent evaluates the data and converts those raw sensor inputs into meaningful alerts before any transmission even happens. This filters out all that annoying, irrelevant noise, like a passing rainstorm or maybe a raccoon tripping a thermal sensor in the woods. It ensures that only verified, actionable data is actually using up your precious bandwidth.
Meanwhile, back at the command center, we've got the Hotot server. Think of it this way. If the agents are the eyes and ears on the ground, the server is the ultimate traffic cop. It's this central messaging framework that takes in all those tiny, curated alerts from the edge agents, validates the messages, logs all the system activity, and then routes the important stuff straight over to the coordination engine.
But here's the cool part. The server doesn't just sit there and receive data. It issues commands, too. When one of the agents detects an anomaly, the server dynamically forms what are called temporary working groups. It actually blasts tasking instructions back out to specific edge agents, grouping them together temporarily to gather targeted, follow-up data for a single mission objective. It's essentially building a custom surveillance team on the fly, purely based on what is happening in that exact moment. How cool is that?
All right, moving on to Section 3, multimodal sensor orchestration, seamless tracking in action. Let's put this into a real-world scenario so we can actually see how this multimodal orchestration behaves out in the field.
Picture this. A suspicious target truck is being tracked via visual sensors, right? Suddenly, the truck swerves behind a large building and completely drops out of sight. Now, in a normal legacy system, that track is totally lost. You're flying blind. But with this setup, the Hotot server instantly and automatically tasks nearby acoustic and thermal sensors to pick up the trail. The tracking is maintained seamlessly, synthesizing data across completely different hardware types and doing it all autonomously.
Just think about the contrast for a second. The old way means some poor operator is frantically clicking around, switching between a dozen screens, just desperately trying to guess which camera that truck might pop up on next. The Hotot way means the software does all the heavy lifting. This automated cross-modal tasking maintains constant situational awareness and absolutely slashes the cognitive load on defense operators. They only have to focus on the actual threat, not on fighting with the software.
That brings us to Section 4. Real-world security applications, where Hotot operates. Now that we know how intelligently it processes all this data, where exactly is this powerful technology actually being deployed today?
Because of its super resource-efficient design, Hotot is incredibly versatile. In defense and national security, it absolutely thrives in strict, bandwidth-limited areas. For disaster response, it gives teams rapid situational awareness even when the traditional grid is completely wiped out. It's a huge asset for critical infrastructure, too. Think autonomous pipeline monitoring, and it allows remote sensing networks to maintain constant, round-the-clock surveillance without needing a human staring at a screen 24/7.
This is a seriously robust framework. In fact, it's so effective that it recently took home a prestigious 2026 R&D 100 award. It was developed by an absolute powerhouse collaboration led by Los Alamos National Laboratory alongside Pacific Northwest National Lab, Sandia, and a few others. And just a quick note, because it's built for high-security applications, it is not open source. For enterprise or research use, organizations literally have to coordinate directly with the Feynman Center for Innovation at Los Alamos just to license it.
Ultimately, you have to remember that Hotot doesn't exist in a vacuum. It sits within this massive wider push over at Los Alamos to build advanced AI capabilities across the board. While other projects there might be focusing on AI for, say, scientific discovery or materials design, Hotot and the Persistent Dynamics platform are providing the highly specialized, battle-tested framework for real-world sensor orchestration.
It really gives us a fascinating glimpse into the future of data management, doesn't it? As our physical environments become increasingly flooded with cameras and sensors, it begs the question, will centralized human monitoring soon be entirely replaced by intelligent, self-organizing edge networks like Hotot? I'm going to leave you with that thought to ponder. Thank you so much for joining me for this explainer, and as always, keep questioning the technology that surrounds us.